In this video, we're going to look at different terminologies that are used typically in business analytics or data analytics. So there are similar corresponding terminologies in classical statistics. Some of these terminologies you may have come across in your statistics classes. So let's look at some of them. Independent variable. Okay, so that's in your regression analysis class, you may have come across that you have x's, and using those x's, you put in a formula, and then you predict the value of y. Those x's, a variable usually denoted by x. So that's what we typically call as independent variable. So it may be like, what is you're trying to predict sales using, say, price and maybe income and inflation rate and interest rate and so on. So these are the price and inflation and etc. So those are your independent variables. So they are not in your control. So those are controlled by external factors. So those are the x's. And in business analytics, they are called attribute or feature or predictor variable or input variable. So these are the terminologies that get used. So when somebody uses terminologies like attribute or feature, then that seems kind of different, but it's just independent variables. Now, dependent variable is what we are trying to predict. So it is usually denoted by y in classical statistics. And in data analytics, we will use words like response variable or target. Target variable is what SAS uses. So we will be using the word target quite often. And that refers to dependent variable, or in other words, y variable. So the other terminologies used are response variable or output variable. But we'll be using target very often. Okay. Next, observation. Observation is a row of records. So a value of y and the corresponding value of all the x's. So in other words, the value of dependent variable and the corresponding value of all the independent variables. So that's one row of data. So in other words, in data analytics terminologies, target value and then the corresponding values of all the predictor variables. Predictor variables are the independent variables that predicts the target. So that's an observation, an instance, okay, a sample. So the unit of analysis. So that's what a customer transaction, for example. So that would be one row of data, or observation. Now, training data, validation data, and test data. So these are three different data sets that are typically used in data mining. Okay, so in old and classical methods, the data available was kind of limited, so we had to use the available data for both prediction as well as evaluating the error rate in prediction. In other words, how well the prediction is working. The same data is used for both. But in big data environment, when we have plenty of data, we separate the data randomly into what is called training data, validation data, and then sometimes if needed, test data. Test data is not always separated out. Okay, there will always be training data and validation data. Okay, but in certain instances, you may want test data as well. So training data is maybe you take a huge database of say 10 million records. So maybe like 50% of it you want to use it for training, and then 30% for validation and 20% for test data, or maybe 60% training and 40% validation. So that's fine too. So using the training data, you develop the model, and then how well the model is doing. So you apply that model to the validation data and then see how close the actual target value in the validation data is to the target predicted by the model. So you use validation to see the error rate in your prediction, because validation data is again data that's available from the past record. So you will already have the value of the target in the validation data. So you compare the actual target that happened to be in the validation data set against the target that the model predicts. And you do the same thing with test data. Sometimes validation data is used in the process of developing the model with the training data. So when that happens, then you need a third data set to actually test the validity of your model. So algorithm is a technique that we use to develop a model. So it could be logistic regression or classification tree, discriminant analysis. So these are methodologies that we will be covering in this class. And then there is what is called supervised learning and unsupervised learning. So these terminologies sometimes are kind of confusing. So there is no supervision going on in these methodologies. It only is that when there are some analyses that we do with the data, but there is no target. Okay? There is no target like, what is the predicted value of sales, for example, how much the customer will spend. That would be a target. We want to figure out how much a person will spend in a sale. Okay. So if that is the case, if there is a target in the data and then you're trying to predict that target, that is called supervised learning. So predict the output value of the target interest using an algorithm. Okay. Whereas unsupervised learning means you have a data set, there is no actual target, yeah, but you want to analyze and understand the pattern. So maybe you have a voter registration database, and then you want to analyze that, then classify the voters in your district into certain kind of homogeneous groups. Okay, so maybe young millennials or seniors and things like that. So you're trying to learn the pattern in the data and then group those the observations into various relatively homogeneous groups. So that's called unsupervised learning. So unsupervised learning means there is no target in the analysis, whereas supervised learning means there is a target that you want to predict. Now, score is the data set for which we need prediction. So remember we talked about training data, validation data, test data. So those three data sets are made from existing data, for which the historical data, where you have all the values of the independent variables and you have the target value as well. So you're trying to develop a model that fits the independent variables or the predictor variables with the target. So once you've developed a model, you've tested it, and you're satisfied, you have a great model, so now you want to deploy the model in production. So a new person comes in, so you have a credit scoring methodology, a model that predicts a particular probability of a customer being a good credit or not, and then you've set up a threshold value with which you can say, all right, we approve or don't approve a particular credit applications. You've developed all that. So now you have a new set of, say, 50 applications that have come through. Now you apply the model to these 50 new applications, and these are new applications, which means you only have the values of the excess. You don't have the value of the target. So this data set is called score data sets, new observations that needs prediction of the target. So you apply the model and figure out what the target value, your predicted target value is. So scoring new data means using a model developed with training data to to predict output values in the new data set. Remember, this new data set does not have a value for target, it only has values for the predictor variables.